We'd like to use completing the square method to solve this particular quadratic equation. And if you watch the completing the square video, you'll realize that when we developed the formula, there was something special about the leading coefficient. Namely, that the leading coefficient was 1. So we can't apply the formula that we developed in the video, but we can be a little bit sneaky and find a way around it. What I was thinking is that we can multiply through both sides by -1. Doesn't change an equation, but if you multiply it by a constant, as long as that isn't 0. Let's see what happens. This gives us x squared minus 2x minus 3 equals 0. Perfect. Now we can employ completing the square. Let's put the 3 to the other side first. So we'll add 3 to both sides. Then we want to take half of this term, which is -1, and square it. Squaring that, we get +1 minus 1. Let's see, this guy is then x minus 1 squared. Make sure you believe that factoring. And we can then add 1 to both sides to get that x minus 1 squared equals 4. If that's true, then x minus 1 is going to equal plus or minus the square root of 4, aka plus or minus 2. If that's true, then I can add 1 to both sides and get that x is equal to 1 plus or minus 2. i.e., x could be 1 plus 2, which is 3, or 1 minus 2, which is minus 1. So the important point to remember is that when using completing the square, the formula that we developed worked only when we had a leading coefficient of 1.